Hello students, we are studying about phenol, its preparation and manufacture. So there I told how to manufacture phenol by cumene process. Phenol by cumene process. The chemical name of cumene is isopropyl benzene and is a modern method used to manufacture phenol on large scale. And using cumene, yes, when it is oxidized by passing air or oxygen, and it gives cumene hydroperoxide. Cumene hydroperoxide. And further it is heated with dilute sulfuric acid, undergoes rearrangement. It undergoes rearrangement to produce phenol and an important byproduct acetone. Important byproduct acetone. Then that can be separated further by fractional distillation method, and finally by steam distillation method we can separate, and purified by distillation. Then at 182 degrees Celsius, whatever we get liquid, and that liquid is said to be phenol. That is called phenol. Next we will study regarding physical properties, chemical properties of phenol. Physical and chemical properties. Now physical state means in physical property we will study common properties of organic compounds. There is said to be physical state, solubility, boiling point, etc. These three are most common. Then in physical state, phenol exists in two forms. At lower temperature, it is up to 42 degree. It is in crystalline form or ice-like crystals. Then at 42 degree or more than 42 degree, it is in the form of liquid. Means it can melt at 42 degree. Phenol is a colorless crystalline solid and melts at 42 degree and boils at boiling point of phenol. There is 182 degree. Boiling point is 182 degree. And it has a strong phenolic odor. Phenols have phenolic smell. We cannot compare with other smell. Therefore, it is said to be having characteristic odor. Phenols have characteristic smell. Then solubility of phenol. Just like alcohols, method is same. In alcohol I told solubility of alcohol due to hydrogen bonding with water. Then here same method, phenol, this is phenol. It is soluble in water due to formation of hydrogen bond with water molecule. Even this one can form hydrogen bonds. Phenol, water. Then water H, oxygen of phenol O. Like this, there is a formation of hydrogen bond. There is called intermolecular hydrogen bonding. And its solubility less due to hydrophobic group. There is a phenyl group is called hydrophobic group. And this prevents formation of hydrogen bond with water. Hence solubility is less compared to alkyl alcohols. Methyl alcohol, ethyl alcohol more soluble, but propyl, butyl, pentyl and aromatic compound like phenol, they are less soluble because they prevent formation of hydrogen bond. This is in the case of solubility. Next, boiling points. Boiling point of phenol. Yes, both are phenols. Between OH, there is a hydrogen bond. Hence, there is a formation of intermolecular hydrogen bonding. Intermolecular hydrogen bonding in case of phenol. Therefore, phenols have higher boiling point when you compare with hydrocarbon having identical molecular mass. Therefore, phenols have higher boiling point due to hydrogen bond. It is called intermolecular hydrogen bonding. Next, oxidation of phenol. See what happen when phenol exposed to air and light. Phenol exposed to air and light. Yes. Phenol react with oxygen, undergoes air oxidation, or even using what potassium permanganate, potassium dichromate. Yes. This undergoes oxidation, but even by air oxidation also it can be converted into what? Yes. It can be converted into para-benzoquinone. It is said to be para-benzoquinone. Para-benzoquinone or phenoquinone. It is also called as phenoquinone. And the color of this one is red. Or even pink color is obtained. But pink color or red color of that phenol compound due to formation of what? Para-benzoquinone or para-phenoquinone. So there is a question in the theory paper you may get. Phenol turns pink when exposed to air and light. Why? This is a question. Phenol turns pink when exposed to air and light. Why? So answer is that undergoes oxidation to form para-benzoquinone and its color is red or pink color. Okay. But you have to say answer main this one. Para-benzoquinone is formed or para-phenoquinone is formed. Then corrosive action. When phenol comes in contact with skin, it forms blisters. And this action is said to be what? Corrosive action. So it is a highly corrosive compound. It can form blisters on the skin, means it may kill the host cells in the body. Then other properties also we can study. There is chemical properties. So in chemical properties we can study its reactions and their mechanisms in what? Phenol. Chemical properties of phenol. Chemical properties. Just to observe the structure of phenol. Now we can study three types of reactions. Reaction due to OH bond cleavage, reaction due to CO bond cleavage, reaction due to aromatic ring. And here reaction due to OH bond cleavage, this part, OH bond cleavage, we can study acidic nature of phenol, then acetylation, benzoylation, acidic nature, acetylation, benzoylation. These reactions involve OH bond cleavage, okay, and oxidation reaction. Here CO bond, but CS bond direct to give CO bond. There is oxidation reaction. Then using zinc dust we can explain CO bond break. Means reaction due to CO bond. And last reactions due to aromatic ring. Like in halorines, you studied about chlorobenzene, bromobenzene, nitration, sulfonation, halogenation, Friedel-Crafts reaction. And these are the four reactions under what? Aromatic substitution or electrophilic substitution reactions of benzene or this aromatic ring. Means this is a third type. Then a special type of reactions of phenol, and they are only due to phenol compound, not any other compounds. They are called Reimer-Tiemann reaction and Kolbe's reaction. Reimer-Tiemann reaction and Kolbe's reaction. So all the reactions we will study in 1 or 2 hours regarding what? Chemical properties of phenol. Next, acidic nature or acidity, acidic nature of phenol. So this part very important. Carefully hear all the points whatever I am telling about acidic nature. Phenol is acidic, not an acid. I will prove phenol is acidic, but not an acid. Just like alcohol. Alcohol is said to be acidic, not an acid. Or there also I told why the compound is called acidic and why it is said to be what acid. Difference between acidic and acid I covered in the alcohol topic. I will repeat once again in case of phenol. Okay. Now, phenol is acidic. Phenol is acidic, not an acid. Phenol is acidic, not an acid. But how to prove acidic? Okay. First reaction, phenol reacts with sodium metal. Second reaction, phenol reacts with sodium hydroxide. ROH, here R equal to aromatic ring, or AROH. Okay. Phenol plus sodium, but this H of phenol compound, then replaced by phenol reacts with sodium metal, and this H of phenolic group replaced by sodium. Then this H goes out as hydrogen. Now balance the equation. Here 1H, there 2H. Therefore multiply through by 2. 2H, 2H. 2Na, 2Na. 2 ring, 2 ring. 2O, 2O. Give a reaction to show that phenol is acidic. There is a question carrying 1 mark. Give a reaction to show that phenol is acidic. Okay, write this equation. Phenol reacts with sodium metal, liberating hydrogen gas, and sodium phenate is formed, or sodium phenoxide is formed. It is also called as sodium phenoxide. Sodium phenoxide or sodium phenate. It is also called as sodium phenate. Okay. Then one more reaction. But here what I told, so phenol is acidic because it reacts with sodium metal, liberating hydrogen gas. Right? Next, phenol plus sodium hydroxide, it can give same compound, sodium phenoxide plus H2O. H of phenolic compound react with OH. HOH react H2O, and O negative Na plus gives ONA. Now this reaction proves what? Phenol is acidic, no doubt, but is more acidic than water, because NaOH plus water, no reaction. NaOH plus phenol, reaction. NaOH plus alcohol, no reaction. And this proves phenol is said to be more acidic than water and alcohol. Yes, again there is one question. Phenol is more acidic than alcohol and water. To prove this, give one equation. Okay, this equation you write. Phenol reacts with sodium hydroxide to form sodium phenate and water. But this reaction shows that, or proves that, phenol is said to be what, more acidic than water and alcohol. Phenol is said to be more acidic than water and alcohol. Now, third point, not an acid. Now I will prove phenol is not an acid. Okay, by reacting with, or by showing the reaction with phenol plus sodium bicarbonate, and right here, right side, no reaction. When you take phenol in the test tube and mix with sodium bicarbonate or sodium hydrogen carbonate, and there is no liberation of gas, or you cannot see in the test tube what bubbles, there is no liberation of gas in the test tube, and that shows what? Phenol is not decomposing sodium bicarbonate into CO2. These carbonates, they are not changed into CO2 gas. If it is converted into CO2, then yes, the compound added, there is said to be acid. But here there is no reaction with sodium bicarbonate. Means phenol is not decomposing sodium bicarbonate into CO2. And this reaction proves that phenol is not an acid. Phenol is not an acid. But there is one more question on this. Phenol does not decompose sodium bicarbonate. Why? This is a question. Phenol does not decompose sodium bicarbonate. Why? Yes, for this answer is because phenol is said to be weaker than carbonic acid. H2CO3. 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 Valency of O 2. Valency of H1. Valency of C4. This structure of carbonic acid. And this compound very weak acidic compound. Carbonic acid means it is obtained by mixing CO2 and water. When CO2 water combine, they can form carbonic acid, H2CO3, and it exists at low temperature. At normal temperature, again decompose to give what? CO2 and H2O. But it is said to be weak acidic compound. Now when you compare what phenol acidic character and carbonic acidic character, carbonic acid acidic character, yes. Carbonic acid, it is weaker than, phenol is weaker than carbonic acid. Carbonic acid itself is weak. When you compare with carbonic acid, it is again weaker than carbonic acid. Therefore, this is the main reason. Phenol is said to be weaker than carbonic acid. Phenol is weaker than carbonic acid. Hence it hence it cannot decompose. Hence it cannot decompose sodium bicarbonate. Phenol does not decompose sodium bicarbonate because it is weaker than carbonic acid. It is weaker than carbonic acid. Like this you have to answer for each questions. Question 1, question 2, question 3. And explain the acidic nature of phenol based on the reactions. These 3 points you have to write. That carry 2 marks. Okay. Next also we can study phenol acidic nature based on the resonance theory. Resonance concept of what here phenol. Yes, based on the resonance concept also we can explain why phenol is called acidic. Right? Why phenol is said to be acidic. Resonance concept. Acidic nature of phenol. Resonance concept. Experimentally, we discussed about acidic nature of phenol. Now we can study theoretical. Resonance concept, there we study electron pair, maybe lone pair or pi-electron pair. Delocalization of these, they can cause acidic nature of phenol. Now first we write ionization of phenol, then resonance structures of phenol and resonance structures of phenoxide ion. And see, based on those, now we can decide why phenol is said to be acidic in nature. Okay. So first ionization of phenol. Under this heading, write first ionization of phenol. See, phenol ionizes to give phenoxide ion plus hydrogen ion, phenoxide ion. This is phenol. Then second, resonance structures of phenol. First I written ionization of phenol. Next resonance structures of phenol. Then resonance structures of phenoxide ion. And based on all these 3 points, we can decide why it is said to be, why phenol is said to be acidic. I will write first phenoxide ion, phenol resonance structures, then phenoxide ion. Okay. Structure of phenol, see here, structure of phenol. Then, so lone pairs present on the oxygen and they are delocalized with pi electrons of aromatic ring. Delocalization of electron pair, there is a lone pair and pi electrons, or pi electron, that is called what, which are in conjugation, it is said to be mesomeric effect or resonance effect, means that undergoes a resonance effect. Because of resonance effect, yes, charge separation occur. O carry positive charge and C carry negative charge. Yes. Further, this undergoes what, resonance, or this negative charge delocalized. Same structures as we studied in haloarine topic. Like this, we studied with using chlorobenzene, nitration, sulfonation. There I told how to draw structures, resonating structures of benzene ring. Now, here negative, this is positive. Negative, positive, new bond. Here new bond you have to write. And this one same as it is. But here para position carry negative charge. Then remaining part same. This part same. O positive, H. Then next possibility. Here negative, this is positive and new bond, this bond same. Yes. And finally, again bond shift here and pi bond shift to O, and again we get phenol. Just observe first and last structure in the series, first and last, only they differ by position of double bond. Here no double bond, but here double bond. Here double bond and here single bond. Here single bond and here double bond. Hence they differ by what, position of double bond. Hence these are all said to be canonical forms or resonating structures of phenol. These are all called resonating structures of phenol. Okay. Next, third, resonance structures of phenoxide ion. Resonating structures or resonance structures of phenoxide ion. O negative. This is a phenoxide ion, and see why it is called stable, because it undergoes resonance. Negative charge on O delocalizing with pi electrons of benzene ring. Now it can form different structures. See here, negative charge shift towards negative charge move towards benzene ring and undergoes resonance, and here double bond and this one shift here ortho position. Now it is a negative O, because when pi bond shift here, plus minus equal to bond, and don't write here plus, you don't get here plus, only negative charge disperse over the ring by resonance. Next, this negative charge again delocalized with pi electrons of the benzene ring and undergo resonance. Negative positive bond, this one same. And one more possibility. double bond here, and finally same structure we get, but change in the position of bond occur. Sorry, this is O negative. Okay, just see the structures 1, 2, 3, 4 up to this. In all these cases, negative charge disperse, delocalize. Negative charge delocalized on benzene ring. So these are the resonating structures or resonance structures of phenoxide ion. These are called resonance structures of phenol, and this is ionization of phenol. Now, write in brief regarding these. Then you come to know why phenol is called acidic. Acidic. Now see here, regarding first point, oxygen atom of OH group linked with sp2 hybridized carbon of aromatic ring. If it is sp2 hybridized, that is called more electronegative compared to sp3 hybridized. Therefore, it has power to attract shared electron towards itself, or electron pair can move towards itself. Therefore, O carry partial positive charge. Means electron density on O, decreases. If electron density decreases, now it tries to attract. Now O attracts shared pair of electron towards itself, and hence it undergoes ionization, or the bond become more polar. If electron density moving towards O, then OH bond become weak and undergo more ionization to give phenoxide ion at H+ or hydrogen ion concentration. If H+ concentration increases in solution, then it is called acidic compound. The compound is said to be acidic. Then think about the equilibrium. When equilibrium shifts towards right side, hydrogen ion concentration increases. Then only the compound is said to be acidic. Okay, acidic. Now we will prove here phenoxide ion stability more than phenol. Its stability more than phenol, but that is based on this one. Based on the resonance structures of phenoxide ion and resonance structures of phenol, now we can decide which is more stable. The negative charge on oxygen of phenoxide ion disperse over the benzene ring by resonance. Therefore, it is said to be, or negative charge on the oxygen of phenoxide ion delocalized with pi electrons of aromatic ring or benzene ring and undergoes resonance, or negative charge on oxygen is dispersed over the benzene ring by resonance. Like this you can write any one line. And this is what stability of phenoxide ion due to resonance. Negative charge on phenoxide ion delocalized with pi electrons of the benzene ring undergo resonance. Due to resonance, it is said to be more stable than, this is said to be more stable than phenol. See why phenol is less stable compared to this one? Because in case of phenol, electron pair of oxygen delocalized with pi electrons of aromatic ring. See why electron pairs are moving towards the ring? Because O is linked with sp2 hybridized carbon, which is more electronegative compared to sp3. Hence, it can attract electron pair towards itself, or it acts as a electron withdrawing group. It withdraws the electron towards itself. Hence, it undergoes resonance, and due to resonance, yes, oxygen and carbon of ring acquire positive negative charge. Means charge separation occur, and here don't say charge separation occur. Here charge delocalized, but here charge separation occur due to resonance. And because of this reason, phenol is said to be less acidic than, phenol is said to be less stable than phenoxide ion. If product ion is more stable, then backward reaction less, rate of backward reaction less, and hence forward reaction is favored. Therefore, if forward reaction favored, hydrogen ion concentration increases. Therefore, phenol is said to be acidic in nature. So I told here 3 points to explain the acidic nature of phenol based on the resonance concept, and better all the three structures you draw. Then write in brief why it ionize and what is the reason for what acidic nature of phenol. Very simple. In case of phenol, oxygen atom linked with sp2 hybridized carbon, and hence oxygen is what, or electron density on oxygen is less. If electron density is less, then OH bond become weak, or it can attract electron pair towards itself and undergo ionization to form phenoxide ion and hydrogen ion. And why phenoxide ion is more stable? Yes, that you have to explain. The negative charge on the phenoxide ion or negative charge on oxygen in a phenoxide ion is stabilized by resonance, or the negative charge dispersed over the benzene by resonance. Hence it is called more stable than phenol. See, why phenol is less stable? Because electron pair of oxygen delocalized with pi electrons of aromatic ring or benzene ring, and charge separation occur. Due to charge separation, it is said to be less stable than phenoxide ion. If it is less stable, then ionization is more and giving what, higher concentration of hydrogen, or equilibrium shift towards right side giving higher concentration of hydrogen ions. And this proves what phenol is said to be acidic in nature. Then in case of alcohol, is very important. Alcohol, see what happened in alcohol. Why alcohols are not said to be acidic? Because alcohol, when it ionizes, consider it is ionizing to form alkoxide ion and S+ ion. But whatever charge is the negative charge, this negative charge on O not delocalized. It is not undergoing delocalizing with R group, because R group is methyl, ethyl, propyl, and they increase. Example, CS3O negative. This is CS3OH. Now see here, electron donating group, methyl electron donating group, it cannot attract negative charge. Hence, this ion, alkoxide ion, not resonance stabilized. If it is unstable and they combine what, hydrogen ion, and means they recombine to give back again alcohol. Hence, what alcohols are said to be weaker than phenol. Alcohols are said to be weaker than phenol. Ethyl alcohol weaker than phenol. Why? Because ethoxide ion is not resonance stabilized, whereas phenoxide ion is resonance stabilized. In other words, in case of alcohol, alkyl group is electron donating group. Alkyl group is, it increase the electron density on oxygen. It increase the electron density on oxygen, and hence OH bond becomes stronger. OH bond become stronger, and they cannot undergo easy ionization. This is one type of explanation. And other type with respect to alkoxide ion. Alkoxide ion not resonance stabilized, whereas phenoxide ion is resonance stabilized. There is the main reason for what, less acidic nature of alcohol than compared to when it is compared with what, phenol, compared with phenol. So this is about phenol acidic nature. Okay. Next we study effect of substituents. If EDG group present on the phenol compound, what happen? Whether it increase the acidity or decrease the acidity. Same type, electron withdrawing group. Electron withdrawing group. But to practice well this concept, then we can understand why phenols are said to be acidic in nature. Effect of substituents. Effect of substituents on acidity of phenol. Effect of substituents on acidity of phenol. Okay. Now consider three types of compounds. First type, phenol. Second type, nitrophenol. Then third type, methylphenol. This is a cresol. If a ring contain OH and CH3 groups, two groups on the ring, then they are called what? Cresols. Phenol, para, nitrophenol and cresol. Paracresol. This group is EDG group, electron donating group. NO2 group, EWG group. Electron withdrawing group, electron donating group. Here no group on the benzene ring, only phenol compound. Okay. Now compare which is more acidic, whether EWG group compound or EDG group compound, and why? Reasons. Okay. In all the three cases we consider ionization again. Ionization of phenol can give phenoxide ion and phenoxide ion and hydrogen ion. If stability of this ion is more, then ionization of phenol is more. But important, stability of phenoxide ion important here. Next, see why phenol is acidic? Because in case of phenol, OH bond is weak and undergo easy ionization to give what? Proton and phenoxide ion. And phenoxide ion is said to be more stable than phenol. Hence, equilibrium shift towards right side, and it is said to be or it produce hydrogen ion and phenoxide ion. Therefore, phenol is called acidic. Okay. Next, para-nitrophenol actually more acidic than this, more acidic than phenol. Now, we will study electron withdrawing group on benzene ring, what happened? Electron donating group on benzene ring, what happened? Okay. And why it is called more acidic than this, more acidic than phenol? Then see here. If NO2 group is present on the ring, what happened? Para-nitrophenol. And I am explaining effect of EWG groups. And EWG groups are NO2, cyanide, halogens, and nitro groups, cyanide compound, and halogens. And these are called electron withdrawing groups, and even carbonyl compounds, aldehyde ketones. They are also called as what? Electron withdrawing groups. If any one of these groups present on the ring, see what happened. Present on the ring. Yes, I have considered NO2 group. According to syllabus, NO2 group is considered, or it is given in the syllabus. What is the effect of NO2 group on acidity of phenol? What is the effect of CH3 group on acidity of phenol? Two types of questions. Yes, these two practice well. Okay, but in general, if electron withdrawing group present on benzene ring of phenol, yes, it increase the acidity. It increase the acidity. Means nitrophenols are said to be more acidic than phenol. Now you have to see here why they are called more acidic. Why they are said to be more acidic. So in case of nitrophenol, yes, NO2 group is said to be electron withdrawing group, EWG group. First you have to write reason like this. Why nitrophenol is more acidic? In nitrophenol, NO2 group or nitro group is said to be electron withdrawing group. It increase the acidity. It increase the acidity because nitro group, it is in conjugation with what pi electrons of benzene ring. Pi electrons of benzene ring. And it also decrease here. Electron density on O, yes. If a pi bonds or negative charge shift this side and electron charge or density of that electron decreases on on oxygen. If electron density decrease, OH bond is weak. If electron density decrease, see here. Electron pair or electron density on O moving towards NO2. If electron density decreases, then OH bond is weak. If OH bond is weak, ionization is more. Ionization is more. Therefore, we get more hydrogen ion concentration. If H plus ion concentration increases, then it is said to be more acidic. Yes, how to answer? Nitrophenols more acidic than phenol and even cresols. Because in nitrophenol, nitro group is said to be, or NO2 group is said to be electron withdrawing group. Electron withdrawing group. Yes, it increase the acidity, means it ionizes more, means it increase the acidity because NO2 group decrease electron density on oxygen or nitrophenoxide ion is more resonance stabilized than phenoxide ion. More resonance stabilized than phenoxide, only phenoxide ion. When you compare, yes, nitrophenoxide ion is more stabilized than what? Phenoxide ion. Therefore, nitrophenols are said to be more acidic. But how to write in one line? Why it is called more acidic? So very simple. First you have to say nitrophenols are more acidic. Because nitro group is electron withdrawing group and they decrease the electron density on oxygen, or OH bond is more polar. OH bond is more polar in case of what? Nitrophenols. Then, but first statement, electron withdrawing group like nitro group on benzene ring of phenol, yes, they increase the acidity. This you have to write first. They increase acidity. Second point, yes, reason why they increase, because nitro group on benzene ring that cause more resonance, means it is involved in the resonance, and nitrophenoxide ion is more resonance stabilized than phenoxide ion, or in other words we can write nitro group decrease the electron density in oxygen and OH bond become more polar and undergo higher ionization or more ionization to give higher concentration of hydrogen ions. I told 2-3 types. Answer you can write anyone in exam. But better, nitrophenoxide ion is more resonance stabilized than phenoxide ion. Therefore, nitrophenols are called more acidic. Anyway, if electron withdrawing group, anyone you write on the benzene ring, they are all more acidic than what? Phenol. More acidic than phenol. Next, among the 3 isomeric phenols, orthonitrophenol, metanitrophenol, paranitrophenol, among the 3, which is said to be more acidic, that also we can study. Ortho, meta, para. Here I have taken para position. Next we consider ortho and meta. What happened? This is orthonitrophenol, this one paranitrophenol. Okay, if it is paranitrophenol, see what happened. Then electron pair on O delocalized, here negative, and it can shift like this. This also shift here, then shift here. Means this favors, NO2 group favors resonance, and this involves resonance. And even left, if it is negative, then shift here, shift here, shift here. Anyway, NO2 group, if it is presented para position, it is what? Resonance stabilized. Then, if it is at ortho position, same type, NO2. But structures are less, but anyway, it is also involved in the resonance. But if it is present at meta position, what happen? Meta position. Okay. Here no double bond, we cannot write moment of the bond. Means NO2 group not linked with conjugated system. Double, single, single. But here double, single, double, single, double. Or double, single, double. But when you compare this end like this, double, single, double, single, double. It is called conjugated system. Next, double, single, single. But here 1, 2, 3 important. Don't say 1, 2, 3, 4, 5. According to nomenclature rules, nearer number you take, nearer. Here common, yeah, maybe right or left, both are same. We can write this type of bond or this type of bonds, both are equal. But in this case, nearer. Okay. Next, if NO2 group presented meta position, NO2 group presented meta position, it is not involving resonance with ring, or negative charge not delocalized with the NO2 group. Hence, meta-nitrophenol least acidic, para-nitrophenol most acidic, and intermediate nitrophenol, ortho-nitrophenol. But all the nitrophenols are more acidic than phenol, because in all the three cases there is a NO2 group, electron withdrawing group. Hence, according to pKa values, now we can say para, ortho, meta, phenol. The order of acidity of nitrophenols: para nitrophenol first, second ortho nitrophenol, third meta nitrophenol. But among the three, least acidic meta nitrophenol, most acidic ortho nitrophenol, because of higher number of resonating structures in para, less number in ortho, least in meta. That's why para most acidic and meta least acidic. But all the nitrophenols are said to be more acidic than phenol. More acidic than phenol. Okay. That's why written here, phenol is least acidic compared to ortho, meta, para. But remember, POM, POM in case of nitrophenols. Okay. If nitro group increase on the ring, here, NO2, 2,4,6 trinitrophenol, 2,4 dinitrophenol. If NO2 groups present on the ring, means EWG group increase on the benzene ring, then acidity also increase. Then you can write order 2,4,6 trinitrophenol more acidic than 2,4 dinitrophenol more acidic than POM and least acidic phenol. So this type we can write its acidic character. Okay. So regarding EWG I told, but in the next video or next class I will explain effect of EDG group on acidity of phenol and remaining reactions, mechanisms, etc. Okay. Thank you.